Hey guys, Mr. Backerberg here. In this video, we're going to look at problem solving. Jorge Poi is called the father of modern problem solving, not just because he was good at solving problems, but he also published his process, and he had a 4-step process that he used. Step number 1 was that you wanted to make sure that you understand the problem. Step number 2, you devise a plan to help you solve the problem. Step number 3 is you carry out your plan, and then step number 4, you look back at the work that you did to make sure that it makes sense. Before we get too far into things, I want to look at each step a little bit more in depth so that we understand what's really happening with each individual step. So step number 1, where it said understand the problem. What does that mean? Well, we want to read the problem as it's stated, and it might take a couple of times. Okay, we want to make sure that we understand the meaning of all of the terms in there, if there's any vocab words or anything like that. We want to make sure that we can restate the problem in our own words. And if we're working with a group of people, we want to discuss the problem with those other people to make sure that we do have a full understanding of what's happening within the problem. We're going to identify all of the information that we're going to need to solve the problem. And then we'll work on finding some of that information that we need from the data that we're given in the problem itself. Step number 2 is devising a plan. So what we're going to do is develop a mathematical model of the problem. Sometimes it's going to mean drawing a picture to help us visualize the problem. We might have to introduce some variables so that we could work on setting up an algebraic model. And we can usually use the statement of the problem itself to help us find an equation or an inequality that's going to relate the variables that we're seeing to quantities that we already know. Step number 3 was to carry out our plan. So here's where we're going to solve our mathematical model. And as we're solving, we also want to be able to support or confirm our solution that we come up with. So sometimes we'll be solving algebraically using everything that we know about algebraic methods. And then we could support those algebraic methods by looking at things graphically or even numerically, maybe using our graphing calculator. Or if we wanted to, we could solve it graphically, but then confirm or support our answer algebraically. Okay, so we want to make sure that we're using 2 different methods so that we can support and confirm our answer. Sometimes we might have to just solve it graphically. Maybe we're not able to come up with an actual algebraic model, so graphically or numerically might be the only way that we can solve it. And then our last step, step 4, was to look back. So what that means is that we're going to interpret our solution within the setting of the problem itself. We want to translate our mathematical answer, our result, into the problem setting and then decide if that result makes sense. So in this example, we've got some engineers at an auto manufacturer, and they're paying students 8 cents a mile plus $25 per day to do some road testing with their vehicles. The first thing we want to figure out is how much did the auto manufacturer pay Sally if she drove 440 miles in one day. And we're going to try to use our problem solving process. So step number 1, we want to make sure that we understand what's happening within the problem. And here's where I'm going to identify some of the information that we're going to need in order to solve this. So we know that we get paid 8 cents per mile, and we also get $25 per day to do this road testing. Okay. Now, in the question that we're asked, we're told that we drive 440 miles. Okay, so all of that information is going to be useful as we start setting things up. Now, as far as step 2, developing a model of the problem, I don't think a visual model is really appropriate here. Drawing a picture of a car isn't going to be very helpful, so I'm going to jump to an algebraic model. So I'm going to start writing out an equation. So I'm going to call this equation P for their pay, and we know they get $25 for sure, but they also get 8 cents per mile. So I'm going to go 0.08 per mile M. So we're going to use that mathematical model to help us figure this out. Now for step 3, to actually carry out our plan to solve this, we know that Sally drove 440 miles. So I'm going to take that value and plug it in for my M. So we get P equals 25 plus our 0.08 times our 440 miles that Sally drove. If we multiply the 0.08 times the 440, we get 35.2. And if we add the 25 to the 35.2, we're going to get 60.2. Now we want to take this and translate this answer in such a way that it makes sense within the problem. We're talking money, so we might as well call this $60.20. Now if we're to confirm this or support this answer, I'm going to pull up my calculator so that we can do a little graphing with it. So I'm going to hit my y equals. Now we used p and m as our variables, but we could easily switch those to y and x. So I'm going to type this in. So we had 25 plus 0.08x. So I'm going to graph this out. Now nothing's showing up here, so we're going to adjust our window a little bit. So I'm going to hit my window button. And here's how I'm going to adjust this. My x minimum I'm going to set at 0. My x maximum I'm going to set at 950. I'm going to leave my x scale alone. For my y minimum, I'm going to set that at 0. And my y maximum I'm going to set at 150. And then I'm going to hit graph. So there's our line. Now if we're looking to confirm our answer, we can hit our trace button and arrow along our line. But it's not going to give us every single value along there. So if we want to find a specific x value, we can just type it in. So if we're looking at Sally driving 440 miles, I can just type in that 440 now and hit enter, and I get 60.2 as my answer, which is what we got before. Since we've supported and confirmed our answer, we're going to make our final statement of our answer. So we know that Sally got paid $60.20 for driving 440 miles in one day. Okay, very similar setup here, except we're looking for something new. This one says that John earned $93 test driving a new car in one day, and we want to figure out how far he drove. So we're going to use the exact same model that we came up with before, except this time we don't know how many miles John drove, but we do know how much he got paid in that day. So this $93 is actually a p-value, so we're going to plug that in on the left-hand side. The first thing we're going to do is subtract the 25 from the 93, and we'll get 68 equals our 0.08 m. Then in order to get m alone, we're going to have to divide by the 0.08. And 68 divided by 0.08 gives us an m value of 850. We're going to confirm this on our graph. So we should still have our graph from when we were solving earlier. We just got 850 as our mile value. Remember, we were using that as our x value. So if I type in 850 as my x value and hit enter, it says that we should get a y value of 93, which represents the amount of money that we're getting paid. So that confirms our answer. So we should make our final statement of our answer. So John drove 850 miles in one day and got paid $93. That's going to be it for this video. Thanks for watching.